This video is designed to demonstrate how to use Stata to conduct a independent samples t-test. And in this case, we're going to use the Are These Students at a Disadvantage data set. So I'm going to go ahead and open that data set. And we can see it's open here in Stata. And so I'm going to go to the data browser and just show you that we have the elite elementary school and their reading scores and the Southside elementary schools and their reading scores. Okay, so the first thing we like to do is look at the data graphically. So I'm going to conduct a histogram analysis, and I'm going to use their reading score, and I want to present that reading score by school. And so I'll go ahead and do that. And so we can see that the data for elite and Southside schools is very peaked. So it has a high amount of kurtosis, and that's because most of the scores are falling in this central part of the distribution. I would say that the elite school is somewhat negatively skewed. The Southside school is a little bit positively skewed. Okay, but we can check for normality, and we can check for homogeneity of variances, which are two important aspects of the t-test analysis. So if we go to statistics, summary, and classical tests of hypotheses, we can look at the variance comparison tests. And so in this case, we want the two sample using groups, and our dependent variable is score, and our independent variable is school, and we can submit that. And let's see, so this window then shows us the variance ratio tests, and we want to look at this middle result, because what this is saying is that elite elementary and South elementary, the variances, which are based on the standard errors, are not significantly different. And we can see that in fact they are not significantly different, because the alpha level is greater than 0.279. No, the alpha level here, 0.2797, is greater than 0.05. So our variances are not significantly different. Now let's see if we can go ahead and do the Shapiro-Wilks test. Distributional plots and tests, and then we go to Shapiro-Wilks test to normality. And I know that's just kind of off the screen, but what we're going to do is we're going to look at score, and then we're going to look at it by school, and then I'm going to submit that. And so what this is telling us is that our data is normal. Okay, so if we look at elite elementary school, that data is not significantly abnormal or skewed or have significant kurtosis, as well as Southside school. And the reason I say that is because these values, or the probability of significance, are both above 0.05. So let's go ahead now and run our t-test analysis. And then we're going to go to t-test mean comparison tests. And so we're going to go to two sample using groups. The variable name is score, that's our dependent variable, and our grouping variable is school. Now we don't have to worry about unequal variances, because we just went through the process of examining those variances. So then we can go OK. And so the output you see here is we have the mean for elite school 65.26 and the mean for Southside school at 60.2. So the mean difference is 5.006. So our question is that mean difference significant? And if we look at this middle part of our analysis, what this is telling us is that this mean difference, in other words, is the difference between the mean for elite elementary and Southside elementary equal to 0. In other words, is the difference due to significance or is it just due to sampling error? Well, in this case, we can say it's due to sampling error because our probability of making a type 1 error is 0.06, which is greater than 0.05. So in this case, we say that these means are not significantly different.